Hello everybody and welcome back to another video. So in this video we're going to be talking about the Josephus problem. So let's begin. Okay, so let's first talk about what is the Josephus problem. So let's say that we have some people standing in a circle and the number of people we have is n. So for this scenario I'm going to do 5, and k is the step count to determine which person is eliminated each round. So I'm going to put 3. So let's say we have 5 people standing in a circle. 1, 2, 3, 4, and 5. So let's count 1, 2, 3. This means that this person is eliminated from the game. So 1, 2, 3. This person is eliminated. 1, 2, 3. Eliminated. 1, 2, 3. And this person is eliminated as well. So this means that our survivor is 4 and 4 is the winner of the game. So this is how the Josephus problem works. So for the Josephus problem we have 3 approaches. So in this video we're going to be talking about the first approach, which has a time complexity of O of n squared, and then in the next video we'll do the second and third approach. So let's now without a doubt I'm going to start explaining the first approach. Okay guys, so this is how the first approach works. So we could imagine it like in array. So for now I'm going to do, let's say n is 5 and I'm going to keep k as 7. So we have 5 elements in this: 1, 2, 3, 4, and 5. Okay, and now as you know that each of these numbers have an index in the array, so there's going to be 0, 1, 2, 3, and 4. Okay, so now what we have to do over here is that we have the index, right? So now when we're going to eliminate one person, so this is what we have to do. 0 plus k minus 1. So for in this example, k is 7, right? So 7 minus 1. Why are we doing this? When we're eliminating a person, we have to do this in the code because the index starts from 0 and we have to start from 1. So we will get 7. We have to do 7 minus 1 to start from this index and not from 0. So if I do 7 minus 1 modulo 5, we have to do modulo the length of the array. So in this case it is 5, so I'm going to do 5. So 0 plus 7 is 7, and 7 minus 1 is 6. So if we do 6 divided by 5, as you know, it is 1. So the remainder over here is 1. The remainder is 1. And now, even if I check it from here, let's do 1, 2, 3, 4, 5, 6, 7. As you can see, this person is going to be eliminated, and we get the same thing as our index over here. So we have index 1 over here, and this person got eliminated. So if we did not keep the minus 1, so we did 0 plus 7, just 7. 7 divided by 5, it would be 2, right? So now if we go from here, 1, 2, 3, 4, 5, 6, 7. And now as you can see we'll get 1 and not 2. So this is why we have to subtract it from there. So yeah, I hope this makes sense. And for the problem we have 2 cases, right? So this is actually a recursive problem, and as you know, for a recursive problem we have 2 cases: the base case and we have the recursive case. I'm just gonna do RE for the recursive case. Okay, we already have the recursive case. The recursive case is this, what we did right over here. 0 plus 7. 0 is actually going to be starting is 0 plus k minus 1 modulo n, or modulo the length of the array. So that's the recursive case. And now the base case is only one element is left in the array. So if in the array, let's say hypothetically that this is the element left, 4, then we're just gonna return this. So this means that the survivor is actually 4. So this is the base case. Now when there's only one element left. So now let's actually start writing the code in Visual Studio Code. So I'm gonna go ahead and flip there. Okay guys, so now I'm on Visual Studio Code, and now let's actually start coding this out. So first we have to, as you know, we have to define a function. You could do any name. I'm gonna define the winner, and as you know, it has two parameters, n and k. So in this, we can actually take a helper function, and we need to have the array as a parameter and the index. I'm gonna do idx for the index. So now, now let's actually first do our base case. So if the length of the array is 1, as you know, we discussed our base case here. If it's 1, what we are going to do is we're going to return that particular element. So it's going to be at index 0, right? So we just return that. And now let's actually start doing our main recursive call. So I'm going to move like right over here. Yeah. So what I'm going to do is idx index. So now we're going to do our main calculation like that we did over here. So id index equals to index plus k minus 1, as we discussed. And we're going to do this as modulo the length of the array. So in this scenario, the length of the array was 5. So now this is what we're just going to do over here. And now we're going to pop that index. Pop stands for delete in Python. As you know, it's pretty simple. And now what I'm going to do is I'm going to move over here. Over here, and now we have to actually define an array for this. So array I in range, I'm gonna do 1 and plus 1. So what happens here is that we're creating an array starting from I, and we're gonna iteratively go through this until we reach n using the index. So now at last, let's actually return this. So you have to return our helper function, right? Helper and our 0. Okay, now let's actually call our function, find the winner, and we're gonna do 5 and 3. Let's try it. So Python Josephus approach 1. Oh, sorry, we have to print it. Print. Okay, we get none here. Let's actually see what's going on. Oh, okay. So guys, the error is that over here we're not actually returning our result, right? So we have to recursively do this. So return the helper r idx. So now this should work. As you can see, it throws back the result 4. So now let's actually, I'm gonna put the link to the GitHub in the description, and now let's talk about the complexity analysis of this. So I'm gonna flip to that page. Okay guys, so if we notice here that we're recursively calling this function again, and we keep on deleting an element until only 1 is left. So this leads us to O of n. And then over here, we're popping an index from the array. So every time we pop an index from the array, this also leads us to O of n. So now in total, this is O of n times n, or O of n squared. So this is actually really bad. And in the next videos, we're going to talk about approach 2 and approach 3, which are way better. And I think this is pretty much it for this video. Hope you guys enjoyed it, and I'll see you guys next time. Bye.